What do you think of when somebody mentions the word robot? It could be the menacing shape of the Terminator, or a Cylon warrior in Battlestar Galactica. Or how about R2-D2 and CP3O in the Star Wars movies? Well, no matter what comes to mind, robots are the servants of the humans, and they seem to be strong, powerful, and fast. Hi, I'm Mike Lee for the National Robotics Education Foundation. We're going to show you the DARPA Robotics Challenge in Pomona, California. These are the finals of the DARPA Challenge. There's no super strong, fast-moving mechanical androids here, but what you will see is the birth of future robotic creations that are built with the mission of performing life-saving search and rescue operations that are too dangerous for humans to expose themselves to. As a former paramedic with search and rescue training, I can tell you that one of the first rules of search and rescue is to not become a victim yourself. You don't take unnecessary risk, and you don't compromise your safety equipment. If you can send in a robot to perform the rescue, or at least clear a path to the victims, then it makes sense to develop these robots to a high degree of capability. The DARPA Robotics Challenge is designed to do just that. Give the development of rescue machines a kickstart in design and development, leading to the production and deployment of the robots to trouble spots around the world. DARPA is the Defense Advanced Research Projects Administration, a division of the Department of Defense, and the main sponsor of the competition. Competing teams were selected from qualifying competition events from 2 years ago. 24 teams from around the world are represented. Teams from Japan, Germany, Italy, South Korea, Canada, and others are participating in the event. Upon arrival at the event, the atmosphere is a midway carnival-style scene with activities for the young and the young at heart. Demos, static displays, and even hands-on activities for everyone with an interest in robots were on display. In this case, you could take one of these little robots home with you. There was even displays of hands-on, or should I say hands-in, and hands-out, to give graphic proof of how the robotics work. Meanwhile, on the track, evidence of the numbers of people in attendance were present. As many as 10,000 people registered for attendance at the DARPA competition. Other demonstrations include a four-legged robot that runs like a dog.
How fast is the MIT?
And just to show that humans are not going to be left out, this two-legged robot called Atreus was on the track, showing how a two-legged robot can operate. It has outstanding stability, as you'll see in just a moment. Watch the technician with the basketball in his hand.
If I wanted to take a closer look, if they allow me to get off of the desk for a few minutes and I head to the expo, where can I see Atreus up close and personal?
Yeah, so we have a tent.
That's pretty good stability. In the Atreus tent, you could get your hands on one of them and actually see how it works.
I'll check back in on Blue in just a moment. Just a quick update for you as well over on the red track. A little bit of a delay.
Now let's talk about the competition itself. The programmers and designers have an ambitious task for the robots to conquer. Let us take you through the course and show you how the robots cope with the challenges of the course. In order to gain points, the robots must first drive a vehicle. Here you see Team NATO JSK's robot named Jackson taken to the course, driving an electric ATV.
Team Robotics is going to punt on the egress, which is the second task of the competition.
It is assumed that the robots will be loaded into the ATV or any other vehicle at an actual scene by their human commanders.
all these robots driving.
Slow and steady as it goes, that way it doesn't make a mistake and get hung up somewhere. Here you see Jackson coming across his finish line in order to qualify for the first point. To gain point number 2, the robots must egress or remove themselves from the vehicles. It is assumed that they have reached their destination, but there are no humans to help them on out of the vehicle. Here we see Team Keist robot named Hugo exit the vehicle. Keist stands for Korea Advanced Institute of Science and Technology. Hugo comes away from the vehicle and is clear. But he must get into his transportation mode. So watch this.
Team HIMC Robotics takes a more aggressive approach and tries to get to the stairs a little bit faster, on 8 points. Delay. Let's take you back to green right
We
now.
return now to Team NATO JSK and Jackson. Jackson will be going for his point number 3, entering the doorway. In this case, the robot must first turn the doorknob, open the door, as Jackson has just done, and walk through the doorway into the course. Jackson is doing a fine job here and goes on to the next task, turning on this valve. He must turn the valve 360 degrees. He's got 180 degrees on there now. And here he goes for the other 180 degrees. At first it looks like he missed, but indeed he is not. A successfully done maneuver.
So green.
The next test, point number 4, is to put a hole in the wall. There's a piece of drywall on the right side of the wall that you see now. But the real trick is for the robot to go and pick up a hand tool that is used to put the hole in the wall. It's not so much to pick up the hand tool itself, but to pick up the hand tool with the on-off switch in the correct position, allowing the robot to turn it on. To earn point number 6, the robots had to remove an electrical plug from its socket and replace it into an adjacent socket. It sounds easy, but that's for a human. Now we see a robot going for point number 7, the obstacle course. In this case, there are 3 lanes. This robot is taking the lane where there's downed building materials, cinder blocks, simulating a building collapse. There's also a lane that allows it to push through or remove debris that's on the ground and in its path. Or there is an escape path going on the outside of the course, but they do not get to score points for taking the escape path. Again, it's easy for us to do this, but it's very tough for a robot that weighs 440 pounds and has a foot the size of a size 9 shoe. Here we see Hubo going through the course with the down materials. He can either pick them up and remove them, or bully his way through it just by shoving it out of the way. In this case, Hubo has taken the shove out of the way method. Each one of his moves is calculated to get the right effect. And as you can tell, the crowd appreciates the effort it makes. Now we move on to the final point, climbing the stairwell. We now return to Team NATO JSK and their robot, Jackson, as he attempts to take the stairwell. All during the time that they're going through the obstacle course, the robots are subjected to radio frequency interruptions and communications cutoffs. This is to assume that in real life, these type of things would happen. The robots are then forced to autonomously guide themselves and keep their balance. As you can see, Jackson is now folding his arms up and in front of him to keep his weight balance correct as he goes up the stairwells. The robots and their teams have 1 hour to complete the course for a maximum of 8 points.
So over on the green track right now, Jackson
Each movement of the robot is carefully calculated, engineered, and then input into the system to throw the command to the robot.
in about 5 minutes over in the
robot
responders
then
demo area
makes its
in the
move.
expo.
A bad calculation can mean failure.
Interesting.
In this case, the operators are not within direct eyesight of the robots. They are dependent upon the sensors on board to give them all the information they need to make the robot move. All during this time, direct communications and radio contact is deliberately jammed and interrupted all the way through to make the robots act autonomously. Here we see Jackson taking that first step. And as you can hear, the crowd is very appreciative of the effort. We now return back to Hubo, and as you can see, he is rapidly climbing the stairs backward. Each robot has its most effective style. In this case, Hubo has a better weight shift going backward. And he wastes no time getting on up the steps. And with that effort, the crowd goes bananas. How's that for appreciation for a robot? Meanwhile, out in the midway, there are many activities for the spectators to participate in. Many of the teams that came across for the competition set up a booth or tent to show their actual machines, engineering, and controllers to the public. One of the things on display was this curious six-legged animal that was remotely controlled. It has a special feature to it. Check out those knobs at the end of the feet. Like that one right there. It not only allows the animal to walk, but to also skate. While six-legged machines are typically related to insects, this insect can do something even better. It's an attack insect.
Stopping.
Very nice.
Detected. Attack. 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 Attack.
Another robotic item on display is this robot soccer player. Although not autonomous, it is fun. It's controlled more like a radio-controlled car. In this case, it has the ability to pick up the ball. And now that it has the ball, it's going to take a shot at the goal. He lines up for the shot. And it's in. Now, getting through the course is not exactly easy for the programmers, engineers, or the robots. So there's reason to celebrate if you make it through the course. This robotic Atlas is celebrating his completion of the course as he waves to the crowd.
In under 51 minutes. Meanwhile, Warner the robot on the red track.
Whoops, what was that? Wait a minute. Let's see that again.
Successfully completing.
Turn a little bit. Whoops. Well, it seems that this one just can't quite take the course, and he collapses on the side rail. But he has gotten through the course and then scored maximum points. He's done his job. That poor one looks like he just couldn't make it through the doorway. And a friend we saw earlier today, Jackson, didn't quite make it through the course earlier in the day, and so he had to be carried on off by his crew. Note that if any of the team members have to touch the robot to make an adjustment and or rescue the robot, the team suffered a 10-minute penalty. The time required to complete the course was one of the factors in the scoring of the competition. Having a 10-minute penalty against you meant you no longer had 1 hour. Instead, you had 50 minutes to complete the course. And if you needed that extra 10 minutes, you were just out of luck. The competition continued all day long. There are 4 identical lanes on the course, so 4 teams at a time could run through the course. That gave the spectators something to watch, especially with the large screen TVs available to monitor each and every lane. This particular robot is now about to turn the water valve, and it's going to do it in fine style. It takes a stab and immediately turns it 360 degrees all in one shot. That's great efficiency and great programming. One of the fastest and most impressive robots of the competition is Chimp. Chimp is owned by Tartan Rescue and is sponsored by the Carnegie Mellon University National Robotics Engineering Center. Chimp gets its name from the way it looks when it's standing still. And right now it is egressing out of its vehicle. Now notice the way Chimp is going to get out. It pushes himself on out using the vehicle itself as a backdrop. Watch his right foot. Chimp has an ambidextrous right foot. You notice there are no feet of the conventional type. They're rollers. We're going to see that in action in just a few moments. Meanwhile, Chimp stretches on out its arms, braces on up, and pushes himself away from the vehicle for a perfect egress.
The awarded point as we take a closer look at Chimp on the green track, beginning its egress, working its way out of the flares.
Chimp was the only robot on day 2 to make a successful egress from out of the vehicle. Now that Chimp has done a successful egress, you'll see how Chimp gets into its normal profile for travel, and hence the name Chimp. There he goes. Chimp is also one of the fastest vehicles to complete the course. One of his runs was under 40 minutes.
Team MIT, 1 foot down, need another one to get into that safety area. And over on the green track.
Like the other robots, he must be very careful about the way he lines up to the doorway and goes through it. That way he doesn't hit the door jamb or the door itself, causing it to fall over.
Here the cheers on blue, Robo Semi continues to drill on the wall. Let's head back to the yellow track. Sarah standing by with Team MIT.
Joined by Russ Cedric, and first of all, how do you evaluate
He slowly crosses the threshold, and as he does, he earns point number 3.
So happy to have seen that egress. We've been working so hard on that. Those of you that were here yesterday might remember.
Way to go, Chimp.
Face first last time.
Once the competition was completed, the awards were given out, and in 3rd place, Chimp with Tartan Rescue. 3rd place, Carnegie Mellon University National Robotics Engineering Center. And here you see the entire robotics team up on the stage. Coming in at 2nd place. Coming in at 2nd place, Team IHMC Robotics, the Florida Institute for Human and Machine Cognition, Pensacola, Florida. The name of the robot, Running Man, and a $1 million award. A well done job. But in first place, it's got to be Team Keist. $2 million. The team from South Korea. Robot name, Hubo. It not only scored the most points, it also was one of the fastest robots to complete the course. Team Keist was one of 3 teams selected from South Korea to participate in the event. And what a great job they did. We congratulate all the top 3 teams as well as all the teams that participated.